think there are two things that I like to emphasize. One of them, being a good programmer is really important. Make sure you're graduating good programmers. The other thing that I think is important to recognize is a non-technical issue, is that unlike when I entered the field, the kinds of problems we solve today are at the degree of complexity and scale that a single superstar is much less likely to really move the needle. And what that means for the way we educate our students is that we need to educate students to think of themselves as a team and evaluate their performance, not as much by their individual prowess, but in what ways their addition will make the team better. And I see that every day at Google, where, the difference between a very good programmer and the ninja programmer in a very complex environment with tens or hundreds of people need to work on the same project. The difference between those two is not their ability to program or their technical prowess primarily. The difference between those two is how they work with their teams. So if you are able to have more team-based projects to sort of understand, to practice that kind of teamwork, I think it's going to help them tremendously in their careers. It's a team sport.
So welcome to Agile Software Engineering, and also a little bit of advice about how to have a terrible experience in this course. My hope is that you'll listen to that and then you will do the opposite and you will have a great experience in this course. You might be here because you think software engineering is about programming. As we just heard from Luis Barroso, it's actually about quite a bit more than that. But even if we look at the programming aspect of software engineering, I think probably my favorite definition is from David Parnas. He's a pioneer from software engineering, and he's noted for his work, among other things, on safety critical systems. He says that software engineering is multi-person development of multi-version programs. Multi-person, we already heard from Luis Barroso. Every interesting software project these days is really a team project in some sense. Multi-version, David Parnas said this long before we had software as a service. But with software as a service, it's pretty clear it's sort of evolving all the time. So there's never just one static version of the software. It evolves over time. Like a shark has to keep swimming in order to live. Software lives because people continue to work on it. So multi-person development of multi-version programs is really the difference between this class's material and a programming class. This is about learning the processes of software engineering. Given that there's more than programming to be done, what are some characteristics of a good software engineer? I'm not going to sort of read the whole slide here. You can always pause the video later. But if you look at some of these characteristics, this is from a series of interviews with very experienced Microsoft software engineers from about 8 or 9 years ago. There's personal characteristics that really speak to motivation, people who do this because they are passionate about it and because they want to really put their heart into it. There's a lot about team skills and being a supportive team member, somebody who believes that when they succeed, the team succeeds, and when the team is successful, everyone on the team benefits. People who are good at making decisions, informed decisions based on gathering information and considering alternatives, as well as having good technical skills, being able to sort of look at a problem, consider different solutions, think out of the box about how to approach the problem. But what is not on this slide? What are not things that make you a great software engineer? You don't see they know how to do React Native apps. You don't see they have great front-end graphic design skills. Or you don't say that, they can stay up all night and pound out a lot of code, right? Things that are sort of stereotypically what many people think make you a competitive software engineer, in the scheme of things, turn out not to be that important. That stuff can all be picked up. So with that in mind, since this is the kind of skills we want you to learn in this class, here's some advice on how to have a terrible time and make sure that you don't learn any of those skills. Skip all the passive learning part. Don't read the book, don't go to lecture, just go right into the coding assignments. And as soon as you get stuck on something, go to the forums. Don't read the book because, hey, that's why we have lectures. Reading is a thing that you do in 240 character intervals. Work by yourself because if you work with other people, you're just sort of giving them the free benefit of your knowledge and you're helping them succeed and spending your time helping yourself succeed. Resist learning new tools. You already know what editor you like and, all these different tools you use for programming. Why bother to take time out to learn something different? The course staff has all kinds of advice because they've taken this class. But hey, they're not the same as you. Maybe what works for them is not going to work for you. Focus on getting points. Grades are really important because when you go out into the field 20 years from now, when you're an awesome software engineer at your company, someone is going to ask what grade you got in CS 169A, and that is somehow going to make an important difference. So, be sure that whatever you do, you're optimizing to get all those points. We're recording all these videos. So, that's what they're there for. Just learn from the videos. And if you watch them enough times, you will get good at this stuff. Every once in a while, something goes wrong. We slip up. Things are going to be late. And, you don't want to leave those points on the table. Coding is, it's pretty time consuming, but you can always multitask. There's always 3 or 4 other windows that could be open. So you can have many activities going on at the same time and make the most of that time you're going to spend on this class. And finally, you're going to hear that software engineering is all about processes for getting multi-person, multi-version software built. But processes are a thing that takes away from coding time. I don't know if my sarcasm delivery is working or not, but let's go through this list one more time. The reason the coding exercises are there to help you practice the stuff that we try to convey in the lectures and in the textbook. So don't jump right into it because you are going to hit obstacles. That's the point, right? Struggling with material is the only way to learn it, but our goal is to sort of pave that road a little bit for you before you jump right in. Do read the book. There's no way we can cover everything in lecture and section that's covered in the book. There's just way more detail in there. So they're designed to complement each other. They're not designed for one to be the replacement of the other. Work together. We will get teams formed as soon as possible. Even though only the last programming assignment is officially a team project, all of the other assignments, we encourage you to work with your team and sort of get used to working together. You will learn from each other at least as much or more as you will learn by working with the course staff. There's a lot of new tools in this course. And guess what? If you go into software engineering as a career, you're going to be learning tools all the time. You're going to be learning new languages, new debugging systems, all kinds of stuff. So the skill of learning how to use new tools and become productive with them, that is a life skill for software engineering. So embrace it. Don't resist it. The course staff have all taken this class. They've done well in it. They have industry experience in many cases. So when they give you advice, it's coming from a good place. It doesn't mean you listen to every word they say, but please do take it to heart. We want you all to be successful. We also really want you to learn this material. There are people who work at GitHub who never got a 4-year degree in computer science or software engineering. At the end of the day, points are not going to matter if you can't take those skills with you, because in an interview, there's no points. There's just what can you demonstrate that you actually know how to do. It's great that these videos will be available, but like we said, this is one component of how you learn these skills. There's also the book. There's working with other students, importantly, on the programming assignments. So don't assume that just watching the videos is enough. Do your own work. Part of it is sort of obvious. It's the right thing to do. And part of it is also that, again, when you get into industry, you have to do your own work. There's sort of no way to violate an industry honor code because there isn't anybody to cheat off of. We're here to help you. There's very generous extensions on everything. You learning the material is the most important thing. And we're trying to remove as many obstacles as possible to doing that. Coding is so hard. I think programming is one of the hardest intellectual things that any human being can do. And it's hard enough under the best of circumstances. So when you're doing it, set the world aside. Keep all the other windows closed. We'll show an example of how pair programming is done in industry. Very often, it's done on computers that are not even your own computer. So there's no sort of temptation to open your email app or to have a message pop up because it's not even your environment. Productivity is so important. Finally, it seems hard to believe, but process is actually really important. We'll talk a lot about Agile during this course, and a lot of people think, oh, Agile, that's sort of the non-process. Agile is a process, but it's one that's relatively lightweight. It's easy to follow. It's not burdensome. And it's amazing how much of a difference it makes when you're trying to build something with other people. So pay attention to the processes. They're not that hard to learn, and they'll make a huge difference. Lastly, some advice on remote programming. During the unfortunate COVID pandemic, remote programming 100% of the time was sort of the only option for a lot of people. We're now getting back to where in-person work is possible again. There's a study that we encourage you to read that basically concludes programmers get less feedback when they're working remotely than when they're working in person. And feedback is basically how you learn, right? It's you get feedback when you make a mistake and you can correct it, or when somebody points out a way to do something better, that's how you discover new knowledge. So again, just reinforcing, work with colleagues when you can. Work with your group, work with your team, pair program, work with a stranger. It doesn't matter, right? But it is a team sport, just like Luis Barroso said. And when you do need support, you're going to post questions in the discussion forums. That's what they're there for. But before you post, search. It's very likely someone has had the same question. You will save both your time and the staff time if your question has already been answered. be civil and be professional. Nothing is really anonymous. And you should really think about this as you're posting in a forum where your coworkers or even your supervisors might be reading those posts, because that's not too far from the truth. Your coworkers are the people around you right now. Your quote unquote supervisors or maybe the staff of the course. We're not officially your bosses, but please affect a professional tone, right? We're here to help each other. When you do post, help us help you by being specific. If you just post a question like, here's my code that doesn't work, here's all my code, here's a long backtrace, somebody tell me what's wrong. That's sort of asking us to do your work, and that benefits no one. But if you say, here's a particular piece of code, and what I thought would happen was the following, but instead, what happened was this other thing, and here's the part of the error message that sort of tipped me off to that, or here's the part of the backtrace where my code is first mentioned, and it's saying that there's a problem around this line, but I don't really see what the problem is. That's really helpful because then we can help you, right? That gives us a specific starting point. And of course, don't post code unless you're asking for help. We will never tell you what to type. Even if you come to office hours, we will never touch your keyboards to type a line of code for you. Our goal is to help you get there yourself. That's the way you learn. So with that in mind, we can start diving into a little bit of the background that motivates what we are going to learn together in this class.